We'll get started. Last few people get here shortly, hopefully. Excellent. So today we're gonna do a couple different things. First, we're gonna kind of go over what to expect on the AP exam for those of you guys who are taking the AP exam. Kind of like how many questions, how much time you're gonna get, the overall format, some strategy things. And then we're gonna take a look at the free response questions from the 2018 AP exam. Maybe work through a couple of those based on what you guys want to see. So that's the overall idea. Also, I know that these next 2 weeks for those of you in AP courses are just crazy, especially if you're taking multiple AP exams. They started yesterday. A lot of you guys were testing yesterday for AP Lit. There were some students testing for APUSH this morning. I think tomorrow there's some people doing AP Gov, I think, right? So make sure to balance your time. After taking tests like that, take a break if you can. Even if you have to go to another class right afterwards, like take a breather. Don't do anything for like 30 minutes. Right? That's very exhausting to do like a 3-hour exam. Give yourself a break. Right? You gotta take care of your noggin. Besides just studying. So keep that in mind. I know this is crazy time. And for those of you who kept me in the loop that you weren't going to be in class for testing, thank you. I appreciate that. That helps. All right. So awesome. Excellent. Now, let's talk about the exam. I'm gonna do my sharing of the screen. Come on. There it goes. Alrighty. So actually, let me do this because it's gonna make my screen easier to see. Awesome. All right, so what to expect on your AP Stats exam? And again, the color choice probably wasn't great, but if you're looking at the shared screen, you might be able to see this a little easier. I don't know. So section 1 will be multiple choice. There will be 40 questions. You'll have an hour and 30 minutes to complete that section. It is worth 50% of your exam score. Right. Individual questions or sets of questions will be based on a shared prompt. So you might have more than one question attached to the same question prompt, or it could just be a single prompt and a single question. It'll be a mix of those things. You will not be able to move back to previously answered questions. Once you submit your answer, no going back. Based on the amount of time you have and the number of questions, you have roughly 2 minutes and 15 seconds per question. Right, so I'm providing you the time breakdown so that you have a better sense of like if you're spending too much time on a question. If you can't come up with some idea of how to answer a question within 2 to 3 minutes, make a guess and go to the next question. You need to give yourself every opportunity to answer the questions you know. It would suck to spend too much time on a couple of questions trying to figure it out and miss answering questions at the end of your 40 questions that you may have gotten right. You got to give yourself the opportunity. All right, section 2 is multiple choice and free response. This is specific to the digital exam. Right, the in-person paper exam, section 1 is multiple choice, section 2 is all free response. They've adjusted this slightly for the digital exam. Again, section 2 is worth 50% of your exam score. The multiple choice part will have 11 questions and will have 25 minutes of time. Similar to the previous section, you get about 2 minutes and 15 seconds per question. Same kind of idea with the multiple choice. You might have a prompt for several questions or just a prompt and a question. And you will not be able to move back to previously answered questions. This is actually the case for the free response questions as well. Once you move past a question, which means you've completed all the parts within a question, you cannot go back to that free response question. In the free response section, you will have 4 questions and an hour and 5 minutes to complete those questions. Right, this gives you just about 16 minutes and 15 seconds per question. So if you give yourself like 15 minutes per question. You got a little buffer of time on either side. All right. And again, I provide the time breakdown so that you can manage your way through the exam better. It would suck to spend 30 minutes on one question and not have enough time to finish the other 3. So you got to be aware of how much time you've used. Right? The first part of the free response section will be one multi-part question with a primary focus on collecting data. One multi-part question with a primary focus on exploring data. One question that combines 2 or more skill categories. Right, so like collecting data is like sampling methods, designing a study, right? Things in that nature, kind of like the stuff from chapter 4 a lot, some of the stuff from other chapters. Exploring data is like finding probabilities, what is this telling us, reading graphs, histograms, pie charts, taking the data and understanding it. Then the mix of everything else is the other question and the investigative task. Right, part B is the investigative task, and that is typically the most challenging free response question. You should spend more time on that than the other 3, if possible. And it is a task that assesses multiple skill categories and content areas, focusing on the application of skills and content in new contexts and non-routine ways, which makes these questions a little bit more hard to prepare for, because they're going to try and give you something you haven't seen before. But it will use the concepts we've covered. You're going to have to be a little creative in how you apply them. So there's that. So what do you need to pass? Right? If you didn't know already, you need a 3, 4, or 5 to get it passing credit on an AP exam. I think that goes for all AP exams. Right? Historically, for this exam, you need to get about 50% to pass. 50% or more will give you a 3, 4, or 5. So reading into that a little bit, you have wiggle room. And this is why if you don't want to spend too much time on any certain question, because you want to get as many points as possible. If it would, again, you got 40 multiple choice questions, say you spend 10 minutes on one question and now you can't finish the last 6 questions, it's possible you could have answered all 6 of those correct. And you still might get the one you spent 10 minutes on wrong. So now you got 7 wrong instead of 6 correct and 1 wrong. So you have to play the game a little bit. All right. Doing better on multiple choice gives you some wiggle room on the free response and vice versa. Even if you do not do some questions but do well on the others, you can still pass. You can get 0 points on a free response question and get like half credit on the rest and do slightly better than 50% on the multiple choice and pass. Okay? There's lots of different combinations of ways to get a passing score. Right? There are several score calculators that you can find online to give you an idea of what score or amount of correct responses you need to pass each section. I have one linked here, put it in the chat. Wants to cooperate, I have to like open it. Let's do this. Actually, I'm going to put the link in the chat and then I'm going to show you guys what it looks like. Where'd it go? Where'd it go? Where'd it go? There it is. There you go, teams. You can do it. So the link to this is in the chat, and now. So this is from a service. They do like online homework and stuff like that. But they have a stats score calculator. There's some disclaimers here, right? This is an estimator. It's projected based on previous years and all that kind of stuff. They have an algorithm. So you can set up here how you do on the exam, right? This is set up for the paper pencil one. We want to set up for the digital. So now it reflects 2 sections of multiple choice, so the number of questions, all these things, right? So look, a raw score, 51 out of 100 gets a 4 based on their algorithm, right? I can slide like the investigative task down to 0, still pass. So theoretically, based on this, you can get just better than 50% on the multiple choice and do poorly on the free response and still pass. How accurate this calculator is, they won't know until all the results come out next year, and they can test and then refine their algorithm. All right. So anyway, you can play around with this type of stuff to get an idea of how much wiggle room you might have. All right. So keep those types of things in mind, right? We get a lot of pressure on ourselves during AP exams. We want to get all the things correct. We don't want to get anything wrong. Understand there is space and room for error. You don't have to be perfect. All right. Any questions about the AP exam? Okay. All right. Also, again, I'm going to put the plug out there. If you are planning on taking the AP exam, please make sure that you have downloaded and logged into the testing app and that it works, that you can access the app demo, the practice exam, all those things. If you've already taken an AP exam, you know that it works. There were some cases where some students were not allowed to get into their exam because they hadn't completed the practice exam. Not sure if that's really a thing. I was told about it from the testing coordinator at another campus. Don't know. So there's that cautionary thing flying around out there. However, if you were able to access your previous exam, do the same thing again. Whatever worked, it should work again. All right, so there's that. So now, next step in the process, we're going to talk about some questions. All right. So in the chat, we have a PDF copy of the 2018 free response questions that were released. Each year they only release one set of questions. They're not going to give all the questions and all the solutions and all that stuff, but we get some. So that's in the chat here. Please click the link, open it up, look through the questions. I'm going to give you all 5 minutes to kind of read through these. Look at them. Do you understand what they're asking? Do you have an idea of how you could solve it? You know, do you understand the strategies you might need? The questions that you answer, know about those things too. You might want to see done in class today or ask questions about in class. All right, so we're going to give you all 5 minutes to look these over, and then I'll put in a little survey similar to what I did yesterday to decide which question or questions we will review. In a landslide of the 11 people who responded, we got question 6. And I totally get it. Question 6 is a beast. The first time I'm still struggling with this question, let's be honest. This one's rough. And I have the solutions. So yeah, let's go over this one. This is the investigative question, the investigative task from this year's AP exam, or from the 2018 AP exam. Yeah, and you really kind of have to work through what's going on in this one. So let's start there. There we go. And actually, I'm gonna need slightly more space with my document camera here. That should help. All right. Okay, so I'm gonna sit down so I can write a little easier here. So if you can't see what's on the screen, those of you looking in class, and obviously that's the shared screen, or it will be the shared screen, let me know. Because I can only see like the top half of it. Pardon me. All right. So here is question 6. All right. Directions. These are the same directions that go with all free response questions. Show all your work, indicate your methods. Right. You're going to be scored on correctness plus methods. All right. So systolic blood pressure is the amount of pressure that blood exerts on blood vessels while the heart is beating. The mean systolic blood pressure for people in the United States is reported to be 122 milliliters of mercury with a standard deviation of 15. The wellness department of a large corporation is investigating whether the mean systolic blood pressure of its employees is greater than the reported national mean. A random sample of 100 employees will be selected. The systolic blood pressure of each employee in the sample will be measured and the sample mean will be calculated. Let mu represent the mean systolic blood pressure of all employees in the corporation. Consider the following hypotheses. We have a null hypothesis that mu is 122 or equal to the national average. The alternative is that mu, right, the systolic blood pressure of the employees of the corporation, is greater than the national average of 122. Right. Question A, describe a type 2 error in the context of the hypothesis test. All right, so we need more paper. Excellent. Actually, use this one. So for part A here, a type 2 error is failing to find evidence for the alternative when it is actually true. In other words, it is failing to reject the null hypothesis when you should. You should find evidence to reject it. A type 1 error is rejecting the null hypothesis when the null hypothesis is true. Okay, so in the context of this hypothesis test, right, a type 2 error would be failing to reject the null hypothesis when the alternative is actually true. Right. In this context, it would be failing to find evidence that the mean systolic blood pressure of employees at the corporation is greater than 122 mmHg when it actually is. Again, those of you in AP English, I apologize for any poor sentence structure. Because it's probably not great, but it works. All right, so here we go. That's our type 2 error, right? As long as you're saying that the type 2 error is essentially failing to find the evidence for the alternative in some way, you should be okay. You can word it differently, like we could say we've failed to reject the null hypothesis when we should. Those are kind of complementary statements. All right. So then we get to question B, where it starts to get crazy. We have lots of stuff going on in here. So assume that sigma, right, standard deviation of the systolic blood pressure of all employees at the corporation is 15 mmHg. Right, so we know the standard deviation. If mu is 122, the sampling distribution of X bar for samples of size 100 is approximately normal. This is important. With a mean 122 mmHg and a standard deviation of 1.5 mmHg. What values of the sample mean X bar would represent sufficient evidence to reject the null hypothesis at the significance level of alpha equaling 0.05? Right? So, lots of things going on in here. We need to use all of this information to come up with an answer. The key thing here is that we are not actually conducting a significance test here. We're using the data and we're using the hypotheses as they're defined to help us with a calculation. So there's a few things that we should note first. All right. The sampling distribution of X bar is approximately normal. That's important because that allows us to use normal distribution and normal calculations. Right. With mean of the sampling distribution equaling 122. And the standard deviation of the sampling distribution of 1.5. Right? So we have that. We also have sample size of 100, right? A population mean of 122. Population standard deviation of 15, and a sigma of 0.05. This is all information that was provided to us here. Right? Because sigma, right, we have a sigma of 0.05, right? And we have a one-sided test. Mr. Mosley. What's up? Brian? Okay, you take all the stuff? Okay, you got it. Right. Brian, you get to go home. They got an off-campus pass for you up at attendance. Take all your stuff. Okay. Sorry for that brief interlude. All right. So ultimately what we're looking for here is if we have something, what value of X bar would cause us to reject the null hypothesis at this significance level? this significance level goes with our 95% confidence, right? But this is one-sided test or one-sided hypothesis. Which means that we can find Z star from table A. Okay, so we find a critical value, right, our Z value, that corresponds with 0.05 on table A. And this is because we have a one-sided test. If we had a two-sided test, we would get the 0.025. We'd kind of split the difference because we'd have a section on both sides of the tail. In this case, if we look at our distribution, we're only looking for the Z that corresponds with 0.05. Can't see that. Sorry, you guys supposed to tell me if you can't see it. All right, so now this is the 95%. If we end up with a value like that's greater than the critical value, that will result in rejecting the null hypothesis. So that's what we're looking for. So that leads us, we want to find the probability of Z being greater than the Z star value that goes with table A over here. So no, sorry. Where's my table? There it is. We go to table A. And it's teeny tiny. Let's zoom in by not zooming in. Focus. There it is. All right, so we find 0.0505 and 0.0495. Those are the closest two values within table A, and this is on the negative side of table A, 2.05. If we follow that over, we have a negative 1.6, and up at the top here, sorry for the movement, guys, we're between 0.04 and 0.05. So critical values, remember, those are always positive. So even though we have a negative Z value that goes with this thing, we're going to use the positive value. And we use 1.645. Sorry, we don't need the probability thing, I apologize. We're trying to find where Z is greater than this when I standardize and things like that. So we find the Z statistic, which will be X bar that we're looking for, minus the null hypothesis mu naught of 122. Thanks. Divided by sigma divided by square root of n. Right? This is how we find our Z statistic. Right? And so we get X bar minus 122 divided by the square root, or sigma divided by square root of n ends up being 1.5 because we have 15 divided by square root of 100, which is 15 divided by 10, which is 1.5. We want to find what value of X bar makes this bigger than 1.645. Okay, so we multiply each side by 1.5. X bar minus 122 is greater than 1.645 times 1.5. We add 122 to both sides. Right, and we can put this through the calculator. we end up with an X bar greater than, whatever, there it is, 124.4675. And that is the value that we're looking for. If we end up with an X bar greater than 124.4675, that would lead us to reject the null hypothesis if all these other things were true. Right. And that was what we were asked to find. All right. What values, any value of X bar greater than 124.4675, right, is sufficient evidence to reject the null hypothesis at the significance level of alpha equaling 0.05. Right. So again, that's a lot of work and it's a lot of reasoning to get here. Is there anything I can clarify on this example or this part of this question? So again, as part of an investigative task, we're using parts of what we know from significance testing, parts of what we know about normal distributions, critical values, all these things, and kind of smashing them together. So it's a little wacky. Let's look at part C. Using the actual mean of 125 mmHg and the results from part B. Determine the probability that the null hypothesis will be rejected. All right. So now we have more math to do. So for this part, and this is where it gets a little more wacky. We have the population mean is assumed to be 125. The mean is 15. And n equals 100. Okay. We want to know probability of X bar being greater than the value we found in part B, because this would give us a probability of rejecting the null hypothesis. Okay. So we standardize the whole thing. We have the probability X bar minus, oh, not that one, that, right? So we're standardizing X bar based on the sampling distribution mean and the sampling distribution standard deviation, right? And then we standardize 24.4675 minus the mean 125, right, divided by 1.5. Again, we use the 1.5 again because of the same thing that we used here, right? Our sigma divided by the square root of n, based on the sample size. Right? And we get the probability of z, because that's what this is, just z. It's our statistic. Being greater than, we push all this craziness through a calculator. We get negative 0.355. And then we consult table A. Right now, keep in mind we're at greater than. Table A always gives us less than. The quick trick on table A is if you want greater than, flip the sign and find that value on table A. Then you don't have to do the complement rule. So where did my table A go again? There it is. All right, so we will find positive 0.355. That's table B. That's table A. I know there's going to be small, but we get 0.3 here. 0.35 is going to be here. It's going to be between these two. Right? We could use the calculator to be even more correct, so to say. We could use the inverse normal, or not inverse normal. Yeah. No. Yeah. Inverse normal distribution on the calculator, but essentially we get 0.64. If we round either of those to do decimal places, we have 0.6368, 0.6406, 0.64, and that is sufficient. All right. So ultimately, we have about a 64% chance of rejecting the null hypothesis and finding evidence for the alternative. Any questions on this part? Part D, what statistical term is used for the probability found in part C? This one doesn't actually have any math involved in it. D, this probability from part C is the power of the test. All right, we briefly talked about power. If you don't remember it, that's okay. It doesn't come up very much. But essentially, the power of the test is the probability of properly finding evidence for the alternative when the alternative is true. And then part E, suppose the size of the sample of employees to be selected is greater than 100. Would the probability of rejecting the null hypothesis be greater than, less than, or equal to the probability calculated in part C? Explain your reasoning. So this actually, when we increase the population, the probability of rejecting the null hypothesis increases. Remember, this is one of the ways that we can increase the power of a test, increase the population size, the sample size, right? And this is because of the math that happens. Right? Basically, the part of the calculation that uses the sample size, right, down here in the square root, will result in a smaller value in the denominator. The smaller that value in the denominator is, the larger the value becomes overall. And even if we keep all the other numbers the same, we're dividing by an increasingly smaller value. Right? And so that causes everything to be more likely to happen, so to say. Our probabilities increase. Right? Instead of dividing by 1.5, we would end up dividing by some larger number. Right? If we go to 1,000, right? We'd be dividing by 0.15 instead, right? Causing this value to change. Let's see what it changes to. For example, we get negative 0.355 when that value changes to negative, or changes to 0.15, right? Which would result in looking at 3.55 on table A, which isn't on table A, but as we look here, we top out on table A at 3.49. We're at 0.99998, almost 100%. Right, so that changes it significantly. We're almost guaranteed to reject the null hypothesis. All right. So as we increase the population or the sample size, the probability of properly rejecting the null hypothesis increases. Okay. What can it clarify? I know that question was a lot. Okay. So that was question 6. We will quickly go over question 5. And I went over it earlier today. Yeah. Where did it go? Where did it go? There it is. All right, guys. I'm gonna quickly kind of buzz through question 5. So we have our 2 histograms here. Zoom, get this guy a little closer now. All right. High school A, high school B. We're representing teaching years recorded as an integer, with first year teachers recorded as 1, second year teachers recorded as 2, and so on. Both sets of data have mean teaching year of 8.2, with data recorded from 200 teachers at high school A and 221 teachers at high school B. On the histograms, each interval represents possible integer values from the left endpoint up to, but not including, the right endpoint. So for example, this first bar for both represents values 1, 2, and 3. This has 4, 5, and 6, 7, 8, 9, 10, 11, 12, and so on. So it clearly defines where our cutoff points are. Question A, the median teaching year for one high school is 6, and the median teaching year for the other high school is 7. Identify which high school has each median and justify your answer. One way to justify this is simply by looking at the histograms. Because of the essentially the weight on the left-hand side here, it kind of makes sense that this median would be less than this median, just from the distribution. We have nearly 80 teachers represented in the first bar. Right? The median is where we cut the data in half, so half of my teachers need to be less than the median and half need to be greater than the median. Half of 221, right? That's 110.5. We've got 80 right here. And they're like almost 35 right here. We got 34 there. We're almost there just between these two. Well, we're there between these two, right? So the median for this one should be in here, which contains 6, right? High school A, 200 teachers, 100 is the cutoff point, right? Between the 100 and 101st, or 100.5, will be the location of the median. We get less than 50 here, less than 50 here. That means the 100th value is somewhere between 7 and 10. This bar contains 7. So the median for high school A should be 7. The median for high school B should be 6. So we can reason about that just with the graphs. We can also use like the formula for finding the location of the median. Right? The median is at the 200 plus 1 divided by 2 location, or the 200 or 100.5 item in the list between the 100th and 101st item or teacher when we're ordered. Right? These values are between 7 and 9, so the median for high school A, 7. Therefore, school B must have a median of 6 because that's the only other choice. It can't both be 7. Okay. Question B, an additional 18 teachers were not included in the data recorded from the 200 teachers at high school A. The mean teaching year for the 18 teachers is 2.5. What is the mean teaching year for all 218 teachers at high school A? Well, remember, the average is if we split all the teaching years evenly among all 200 teachers, each teacher would have 8.2 teaching years. So if I multiply it by 200, I get the total number of teaching years for all the teachers there, and then divide it. So if I multiply the average for the 200 teachers by 200, multiply the average for the 18 teachers by 18, I get the total number of teaching years for all teachers, divided by the total number of teachers, which is now 218, and I get the new mean. Right? And so we get the mean teaching year for all 218 teachers at high school A is 7.7. And so this is using what the definition of an average. Last thing, question C, the standard deviation for the teaching year in 221 for the teaching year for 221 teachers at high school B is 7.2. If one teacher is selected at random from high school B, what is the probability that the teaching year for the selected teacher will be within one standard deviation of the mean of 8.2? Justify your answer. This one is a little misleading because they're using mean and standard deviation with a graph that is not symmetric and not normal. Right? If this was normally distributed or if it was symmetric, we could almost just right away say 68%. Right? That's our rule, 68, 95, you know, that rule that we have. But it's not. So we need to do a little bit of math and find the upper and lower bound of within one standard deviation, which we have here. So we have the upper bound is 8.2 plus 7.2, it's 15.4. The lower bound ends up being 1. Right? So we want all the teachers that have between 1 and 15 years teaching. If we go back to the graph, we have enough, we can see enough here to determine the count for each of these bars. Takes a little working out, but we can. Right? And just to double check, if we add all these up, it does add up to 221. Right? And so we're using these 5 bars and adding those up, because these 5 bars represent all the teachers with between 1 and 15 years teaching. We add them up, divide by the total number of teachers, we get 0.855. All right, so there are 189 teachers within one standard deviation of the mean, having between 1 and 15 years teaching. So there's about a 0.855 probability that the teacher selected is within one standard deviation of the mean of 8.2. And that's what we get there. Is there any questions on this for your response question? Okay, so we're gonna stop there because that was a lot, and we're right at that hour mark, so I think that's good. Okay, so the AP exam is basically 1 week away for AP Stats. All right, I will see you guys 2 more times next week, hopefully, and then you'll have your test. So next week we'll do a little bit more review. Hopefully I'll be able to answer more questions for you guys, or specific questions if you have them. If you do have any specific questions or things you want to make sure we go over, please let me know so that I can make sure to go over those things. Otherwise, I'll probably have a selection of other free response questions and other things that we want to look at. And try to prepare as best we can for that AP exam. If there's any other questions, comments, or concerns, anything else you need support with, please make sure you let me know. Other than that, that's all we got for today. Have a great rest of your day and a great weekend, and we'll see you next week.